every day. Therefore, also the name public toilet of SQL Server, every shit happens in TempDb SQL Server. What's the problem? We have only one toilet. Imagine you are all databases, you want to go to the toilet, there's just one toilet for that football stadium. Means there's a huge concurrency problem within TempDb because we have only one TempDb for SQL Server instance. So Microsoft just has introduced a performance bottleneck by design, so that we have fun with our applications on SQL Server. As the name implies, TempDb is just a temporary database, means when we are restarting SQL Server, or when SQL Server crashes and we are restarting SQL Server, TempDb is just recreated on startup. SQL Server just makes a copy of the model database, and out from that copy of the model database we are getting our TempDb. TempDb itself is using the recovery model simple, means we don't need transaction log backups. Doesn't matter, because when SQL Server crashes, nothing happens, because as we have said, TempDb is just recreated during startup. And finally, we have just one file group, the primary file group within TempDb. By default, when we are running with a default installation of SQL Server, we have crazy default settings for TempDb. With a default setting of the MDF file of 8 megabytes and a transaction log file of 1 megabyte. Who has already seen a TempDb with 8 megabytes in production? Nobody. So those default settings are just crazy by default. Means when we're restarting SQL Server, maybe we had a TempDb with 1 gigabyte of data, SQL Server again allocates a data file of 8 megabytes. So when we know that our TempDb grows over time, for example to 1 gigabyte, it's a good thing to set and change those default settings, because they are by default just crazy. Swap, detach, attach, also not possible. As I've said, when we're losing TempDb, we have lost SQL Server. Which user objects are stored within TempDb? Temp tables, global temp tables, which are temp tables across all sessions, and as I have said, also table variables. So when you are creating a table variable, that table variable is persisted within TempDb. And table variables have by design no statistics. Any idea why we have no statistics on table variables? Sorry? Yep, there are no recompilations. So mainly when you are working with temp tables, you have a huge amount of recompilations in your stored procedure, because when you are changing or when you are creating a temp table, you are changing your database design, means SQL Server has to recompile that stored procedure. When you are inserting data into that temp table, you are triggering a statistics update, so SQL Server again has to recompile the remaining part of the stored procedure. Therefore, Microsoft has provided us table variables. When we create a table variable, it's just a variable, we are not changing our database schema. So the first recompile is solved, and the second recompile, which we are triggering during statistics update, is solved by not using statistics. So a very simple fix. So when you are working with table variables, SQL Server always assumes just one row, which can also introduce interesting side effects and performance problems when you are dealing with table variables. What internal objects we are storing within TempDb? As I've said, if we are doing nothing, SQL Server internally will always use TempDb. For example, when you are running consistency checks through dbcc checkdb, dbcc checkdb allocates space in TempDb. When we have execution plans with sort operations, hash operations, those operators can spill over to TempDb when SQL Server underestimated some memory grants. When you are working with cursors, when you are working with service broker, well, service broker doesn't apply because we've seen nobody is working with service broker. But if you're using service broker itself creates work tables within TempDb. When you're using query constructs like group by, sort, order by, distinct, and so on, all those operators can consume space and memory within TempDb. So the conclusion here is, as you have already said earlier, every one of us is using everyday TempDb, as long as we are working with SQL Server. Version store was introduced back with SQL Server 2005, optimistic concurrency. SQL Server provides us here two new isolation levels, with committed snapshot isolation and snapshot isolation, and both isolation levels are working with TempDb. So SQL Server uses here so-called row versioning technology to provide us consistent reads without acquiring shared logs. So when you are using optimistic concurrency, readers are not blocking writers anymore, and writers are not blocking readers anymore. If you are running online index rebuilds, which are available in the Enterprise edition of SQL Server, you are also using a specialized version store, which is also persisted within TempDb. SQL Server provides us a huge amount of different performance counters. So when you go to Perfmon, you will see that we have various performance counters with which we can track and trace what objects we are creating within TempDb, how much space we are using within TempDb. So let's go to SQL Server and let's work a little bit with temp tables and table variables. So I have here SQL Server 2012 instance. And in the first step, very simple, we are creating a temp table. Very bad table design. Every record is 8 kilobytes large, means for every record we need one page within SQL Server. The next step, I'm inserting 200 records. When we do a select against our temp table, we are getting back those 200 records. When we look at the execution plan, you can see estimated numbers of rows is 200, actual numbers of rows is 200, means with temp tables we have accurate statistics in SQL Server. We can use the dynamic management view systemdb session space usage to ask SQL Server how much space we are consuming. So when you're doing a plain select against that view, you see which session is using how much space within TempDb. So for example, when you have a huge growing TempDb, you can ask SQL Server how much space we are currently using. When we restrict on our session, you can see that we are currently using 208 pages of 8 kilobytes within TempDb. The next step, I'm creating a table variable. As the name implies, it's just a variable in memory construct. Not really. When we're creating that table variable, that variable is still persisted within TempDb. So I'm creating that table variable, inserting 4 records, and selecting from that table variable. When we look on the execution plan, things have changed. Estimated numbers of rows 1, actual numbers of rows 4. We have no statistics. The query optimizer just assumes hard-coded 1 row. That's bad. So table variables make only sense when we're dealing with a small amount of data. When we're dealing with a larger amount of data, temp tables are very, very good because temp tables are providing us accurate statistics. with the disadvantage of recompilations. So table variables and temp tables just have different use cases within SQL Server. And when we now do select again against just the TempDb session space usage, you can see we are using 213 pages for our session. Means for the table variable we needed 5 additional pages. 1 index allocation map page and 4 data pages. They are still persisted physically within TempDb. So the table variable is not an in-memory construct. And as you can see, those 5 pages are already marked for deallocation because the table variable is already out of the scope. Our temp table still exists, means when we are now dropping our temp table, those additional 208 pages are also marked for deallocation. Takes now around 1 minute, and afterwards those pages are just deallocated from TempDb. So very simple proof that table variables are also persisted physically within TempDb. Makes sense? Perfect. So let's jump over the version store and let's talk a little bit more about specific performance problems in TempDb that you will see for sure. One specific problem in TempDb that you're always seeing when you're running a larger serious workload on SQL Server is Latch contention. Who knows what the Latch is? Who knows Bob what? Come on, he has made the keynote today. Well, I was sleeping in the hotel. But Bob Watt is the guy who had made the keynote today, and Bob will have tomorrow a session about latches. So he will show you in very great detail what latches are. Today, I'm just telling you that a latch is a light-wired synchronization object within SQL Server which is used by the relational engine. Means when we are accessing a page in memory, in our main memory, SQL Server has to synchronize that access among multiple threads. And for that synchronization, SQL Server is using a so-called latch. The latch can be applied, for example, on a specific page in SQL Server. I will also talk a little bit about performance issues regarding I/O space issues and some problems regarding the transaction block. As we have said, a latch is a light-wired synchronization object used within the relational engine of SQL Server. Means when we are writing, when we are changing a page in main memory, nobody else can read and write from and to that page concurrently. This means when you are changing pages in memory, you just have single-threaded access. Otherwise, you would have lost updates. Means one change is overwritten by another change. That's a huge problem for TempDb. With TempDb, we are always creating temp tables and table variables as we have seen earlier. When you are creating table variables, temp tables, SQL Server has to access specialized pages, so-called PFS page, page read space page, GUM and SGUM pages, global allocation map page and shared global allocation map page. Means when we are creating a huge amount of temp tables and table variables concurrently across a huge amount of users, we have a so-called latch contention on those specialized pages. Here you can see what happens when we are creating a table in SQL Server or a temp table in TempDb. The first step, SQL Server has to read the so-called SGUM page, shared global allocation map page, to find a mixed extent which has at least one free page available. An extent in SQL Server are just 8 contiguous pages of 8 kilobytes. So an extent is always 64K large. SQL Server also has to read the so-called PFS page, page free space page, and when those pages are currently latched by another concurrent query, SQL Server will report us a so-called page latch wait time. Opis is also making a session tomorrow about wait statistics and wait times. Who was yesterday in my pre-count? Perfect. All the others have missed some great content. As we have said yesterday, every time when we are executing a query in SQL Server, a query will always wait. So when we are accessing a page in memory, that page is currently latched by another query. That query produces a page latch wait time. Means we are waiting for accessing memory regions in the main memory of our system. Okay, just think about it. We have concurrency issues in the main memory of SQL Server.exe, in the process space of SQL Server.exe. How can we resolve that latch contention? By using multiple TempDb data files. When we are using multiple data files for TempDb, we are getting multiple copies of those specialized pages. SQL Server implements a so-called round-robin allocation. So if you have multiple data files for TempDb or even for a user database, SQL Server allocates space in a round-robin fashion. The first extent in the first file, second extent in the second file, third extent in the first file, fourth extent in the fourth file. Means we have concurrent access to those specialized pages because of that round-robin allocation algorithm. So if you have latch contention, you can solve it by applying multiple TempDb data files. Microsoft has made in the last millennium the recommendation that we should have a one-to-one mapping between CPU cores and data files. This doesn't work anymore because we can have servers with 256 or even 512 cores. So this doesn't really make sense anymore. So as a good estimation, you should have around 1/4 to 1/2 of data files as you have CPU cores. But you really have to benchmark it with a baseline. You know that word from yesterday, baseline. You have to benchmark it with your baseline in which scenario your TempDb performs best. Question?
Sorry, I thought that's the latest Microsoft recommendation on actually assigning the files is actually the number of the NUMA cores, or all the NUMA groups on the server. Is it?
No, doesn't have to do anything with NUMA nodes.
Well, that's the recommendation from Microsoft.
I don't think so.
I know it. Yeah, we can check it out.
Okay. But most important point here is don't use the Microsoft recommendation which was suggested in the last millennium. It's the same with the page life expectancy of 300 seconds. Forget it. Okay, let's have a look on that. So I'm running here, as I've said, on SQL Server 2012, and I have the default bad public toilet. So just the default settings. Just one data file, one transaction log, nothing more. So let's create a new database. And let's create a simple stored procedure that everyone is using every time. Create a stored procedure, we create a temp table, we create on that temp table a clustered index, unique clustered index so that we get a nice tree structure. we are inserting 10 records. Nothing special. Okay? And in the next step, I'm creating another stored procedure which just calls the other one that we have created previously in a while loop 100 times. Execute that stored procedure. Perfect, it works. Let's deploy it to production. Not so good. We were just running with one user. With one user, nobody else blocks us in SQL Server. We are the one and only person, besides the background processes. So what we can do, we have to make a stress testing. Microsoft is providing us the so-called RMM utilities. You can download them completely free from Microsoft. Just look for them. And within those tools, we have a tool called ostress.exe. With ostress, we can simulate multiple users. So what I'm doing here, I'm executing that specific stored procedure with 100 users, the last parameter. Of course, with 100 parallel users, our SQL Server will react differently. And in that case, with the creation of that temp table, we are hitting Latch contention within TempDb. So let's copy that command line. Let's go to the command prompt. And I'm opening Activity Monitor. We're executing that. We're running with 100 users on a MacBook Air. And as you will see in a few seconds, we will have a huge amount of waiting tasks. How much? Almost 100. Because we have single-threaded access to those specialized pages in TempDb. Just think about that. It's like a door, single-threaded access. One person after one person. The same currently occurs within the process space of SQL Server.exe. We are permanently changing those specialized system pages, PFS page, GUM page, SGUM page. And we have single-threaded access. So just one session, one query after the other one. Took around 1 minute. We can run that again. And when we look to system always waiting tasks for our user sessions, you can see we have here every time waits. 83, 99, perfect. 99 waiting tasks out of 100. Single-threaded access to those specialized pages. With a wait type, page latch shared. We want to read from that page. Someone else blocks us in memory. Page latch exclusive. We want to write that to that page in memory. Someone else is blocking us. And you have here the resource description. Database ID 2, file 1, our default file, page ID 60. System page within TempDb. Just single-threaded access. So very, very simple to reproduce Latch contention within SQL Server. 57 seconds for that workload. That's our baseline. So what we're doing in the next step, we are reconfiguring SQL Server. In the first step, you should give the data file a reasonable size. As you have seen with that workload, our TempDb already has grown to 22 megabytes. So running a TempDb with 5 megabytes doesn't really make sense. How large your TempDb should be depends on your workload. Just look how large your TempDb currently is. So what I'm doing here, I'm just setting the default data file to 512 megabytes. And I'm adding now one additional file. So we have now two data files for our TempDb instance. So when we go to our file system, you can see we have for TempDb two files. Means when we are allocating now temp tables, SQL Server is making a round-robin allocation between both files. One temp table here, one temp table here. In every file we have those specialized system pages, means we can concurrently access those system pages. Just think, we have two doors out of that room. We can parallelize the running out after the session. It's the same here with TempDb. When we are rerunning that workload, we can concurrently latch and access those specialized pages. Okay? You always have to make sure that the files have the same size. Because in addition to the round-robin algorithm, SQL Server also makes sure that all the files are full at the same time. Means when you have one file with 1 gig and one file with a half of a gig, SQL Server makes sure that both files are full at the same time. SQL Server makes 2 allocations in the larger file, 1 allocation in the smaller file, 2 allocations in the larger one, 1 allocation in the smaller one. So your allocation system isn't really balanced anymore. So if you are running with multiple files in TempDb or even in a user database, you have to make sure that all the files have the same size. So let's run that workload again. We have here also again some wait. Now we are waiting on the transaction log. As I've said yesterday, the final bottleneck in SQL Server is always the transaction log. So now we're just producing a wait type of record. We're just waiting on our transaction log. Of course, within that VM, I have just 2 cores. Means I'm not gaining here too much performance, but imagine what happens if you are running that workload on a huge system. For example, with, let's say, 32 cores, 64, 128. You have just a better possibility to concurrently access those pages in memory. As you can see, we're a little bit faster, 38 seconds. So we are almost 20 seconds faster. Just by reconfiguring TempDb. Just think about that. We haven't changed our workload in any way. We have just reconfigured TempDb. Amazing? Perfect. So that's the first thing that we should do. We should give TempDb multiple data files. With just one data file, you have mainly synchronous access to those specialized system pages. In addition, SQL Server is also able to cache temp tables. So what SQL Server is doing when we are dropping a temp table, you have seen earlier, SQL Server just has marked those pages for deallocation. They are marked for deallocations, they are not really deleted at that point when we are executing drop table my temp table. Means SQL Server caches here the first index allocation map page and the first extent, the first 8 pages of that temp table. Means when we are recreating the same temp table again with the same structure, with the same schema, SQL Server can reuse that temp table without accessing those specialized system pages. Okay? That temp table caching is only possible with some prerequisites. For example, we are not allowed to use DDL statements within our stored procedure. Just think back what I have done earlier. I have created a temp table, and afterwards I have created a unique clustered index on that temp table. Means I have introduced a DDL statement, means SQL Server isn't currently able to cache that temp table. Means when we are running that stored procedure 1000 times, we are allocating that temp table physically 1000 times. Very easy to show you that. SQL Server provides us a performance counter temp table's creation weight. All SQL Server relevant performance counters can be accessed through the dynamic management view system OS performance counters. So what I'm doing here, I'm grabbing that performance counter, I'm running my workload, afterwards I'm reading the performance counter again, and I'm just calculating the difference. So when you're on a development system where you're completely alone, you can see how often SQL Server has created a temp table. When we go down, you can see that we have created 1000 temp tables for every iteration. So SQL Server isn't able to cache that temp table by now. When we look up on the definition of our stored procedure, you can see create table and create unique clustered index. So we have a DDL statement in our stored procedure, means SQL Server isn't able to cache that stored procedure. How can we fix that problem?
Migrate to 2014, so it's supposed to do it in one statement.
Yes. We can create a primary key constraint. A primary key constraint is by default enforced for a unique clustered index. So we're just specifying a primary key constraint, and we're also getting our unique clustered index in the background. So I'm altering that stored procedure and specifying the primary key constraint. With the primary key constraint, we're also getting a unique clustered index in the background. When we run that workload again with comparing the performance counter, just one temp table creation. We have created our temp table in the first step, and then we have just reused that temp table over and over again. So we have just accessed those specialized system pages once for the first creation of the temp table. So what we can do now, we can run our workload again with a new baseline, 38 seconds. Let's run it again and let's see how fast we are again. Hopefully we are faster. So let's see what happens. We have to beat 38 seconds. Finish. 25. Amazing. Where are the standing ovations? No, just kidding. Initially, we have started with 57 seconds. We've just improved that specific workload by 100%. Just think about that. Reconfiguring TempDb and making a simple change within our stored procedure. 100% improvement. TempDb, performance bottleneck by design. Questions on that? Question was, what about non-clustered indexes? When you're creating a non-clustered index on a temp table, you are again mixing DDL statements. With SQL Server 2014, you can also create non-clustered indexes inline, which is used for hackathon in memory OLTP. So with 2014, you are also able to cache and reuse that temp tables as long as you are creating those non-clustered indexes inline. So that's also a nice side effect. But mainly the inline creation of indexes is used for in-memory OLTP. Because when you're creating that table, they are compiling everything down to C code and the DLL, which is afterwards loaded into the process space of SQL Server.exe. Other questions? So you are amazed. Nice. If all those things doesn't help you, forget SQL Server. No. In that case, SQL Server provides us a trace flag. SQL Server provides us for everything trace flags. With the trace flag 1118, we can instruct SQL Server that we are not using mixed extents anymore when we are allocating new pages. With that specific trace flag, SQL Server is only using uniform extents, means SQL Server doesn't have to access that Aschenbrenner page anymore. This trace flag can help you with SQL Server 2005, but not on higher editions anymore because Microsoft has already improved that allocation algorithm. Who is using 2005? Perfect. Almost. Okay, who is using 2000? Maybe you all know 2000. No. So with 2005, there were some cases where all those tweaks that we have seen doesn't help too much, and in that case you can help SQL Server by enabling that trace flag. Okay? Means when we're creating tables, tables are always created in a uniform extent. This also applies for our user databases, not only for TempDb. The side effect is here that a new table is always at least 64K large. When you are using mixed extent, the first 8 pages are allocated in mixed extents, means that the table grows from 8K to 16K, 24, 30, 32, up to 64K, and the 9th page is afterwards allocated in a uniform extent. So the side effect is just that smaller tables are initially 64K large. Let's talk a little bit about performance. Question is always on which drives should we put TempDb. The nice thing is we can ask SQL Server about the latency times of our files. There's a dynamic management function called system.io virtual file stats, and with that dynamic management function, SQL Server is telling you the latency times. So it doesn't make sense to put TempDb always on the fastest drives. Imagine you are not using TempDb too much. Maybe you have on another database more I/O performance problems. So just ask SQL Server through that dynamic management function how your performance is. And if you see that you have high latency times in TempDb, then you can think about doing something about that specific program. But in the first case, you should think, how can I reduce the access to TempDb? Maybe you're using a huge amount of temp tables which aren't really used. Okay? I can also show you that dynamic management function. We have 2 parameters. We have a database ID, for example 2 for TempDb and file ID. With a null, we are getting back information for all our files on our instance. So we have here now our transaction log file, our data files, and what we have here are the number of reads, the number of bytes that we have read, and we have the so-called I/O stall time. That's the latency time. Since the last restart of SQL Server, so when we're dividing those values, SQL Server can tell us what is the average latency time for reading and writing to specific pages in SQL Server. I have here a simple script. Which I have stolen from Paul Wemmer. And Paul is doing all those calculations for us. As you can see, we have our read latency, we have our write latency, and we have the overall latency, the average between read and write. As you can see, we have TempDb here at the very end. So when you see that you don't have a high latency in TempDb, it doesn't make sense to put TempDb on faster drives. Maybe it makes sense to put your transaction log on a faster drive when you have a write latency of 20 milliseconds. For a transaction log, the write latency should be as small as possible, because SQL Server can only commit transactions when we have written out those transaction logs physically to the transaction log. With SQL Server 2014, Microsoft provides us delayed transactions. Delayed transactions means we are immediately committing transactions without waiting, writing out transaction log records. Means when you are using delayed transactions, you are telling SQL Server, hey SQL Server, I want to lose data. Just think about that. So delayed transactions, I have a really mixed feeling about that. Because when you're thinking about the ACID properties of a transaction, you're just crossing out the D for durability. You are allowed to lose data with delayed transactions. Of course, you're getting better performance. Depends what you want to have. Data loss or good performance. Okay? So just think about that when you're thinking about moving TempDb to different drives. Just ask SQL Server what are my latency times, and based on those latency times you can decide if it makes sense to move TempDb to different drives.
Numbers.
Yeah.
Route 1, read latency 9, write latency 0, and latency 9, and so 70.
Sorry?
Could you expand those?
To that row? 70?
2, 0, and 0. What was?
I have no idea. I think it's the... No, I have no idea. It's not my script. It's not my script. That's not my code. I have no idea. That's not my code. Ask for. I have to check it. I have really no idea. Sorry. So when you're executing something, also think a little bit what you're executing. So it's the I/O stall time divided by the number of reads and number of writes. I have to check that. Normally, I'm using always the read and write latency, because that overall latency doesn't tell you too much. But you can see the read and write latency separately, but I really have to check the latency, what it really means. But as we have seen yesterday, we have mainly or almost always looked at the read and write latency. Other questions? Okay, let's continue. So a very, very important dynamic management function within SQL Server to determine what are our read and write latencies from a SQL Server perspective. SQL Server also provides us some other dynamic management views with which we can ask SQL Server how much space we have allocated in TempDb. Imagine you are going to your file system and you see you have a TempDb database of 10 gigabytes. The first step you're asking, okay, who is using all that space? For that reason, we have 3 different dynamic management views. With the first one, TempDb file space usage, we can ask SQL Server how much space we are using in every file. In the next step, we can zoom in to the specific sessions, as we have done it earlier. So SQL Server is telling you how much space is used by every session within TempDb. And finally, we can zoom in on a request level, TempDb task space usage. Imagine you have a stored procedure, and within that stored procedure, you are allocating a huge amount of space in TempDb. What you can do, you can put in that stored procedure at various places a simple select against TempDb task space usage, and you are just restricting on your specific session ID. In that case, SQL Server shows you how the TempDb space changes over time during the execution of your stored procedure. So you can see which statements are allocating how much space in TempDb. Okay? So that's also a very, very powerful dynamic management view, TempDb task space usage. But it will show only an output when a query is currently running. So when no query is running, you will see nothing in that dynamic management view. So mainly it makes really sense when you're using it to track within a stored procedure how much space you are allocating at specific points during the execution of that stored procedure. As we have said in the beginning, TempDb is using the recovery model simple, means we don't need to do transaction log backups. Doesn't make sense to make transaction log backups with TempDb because when our SQL Server crashes, TempDb is recreated after restart from the model database. So we don't need to have transaction log backups. The most important thing here is that we can have problems with the checkpoint process. The checkpoint process runs regularly around every minute in SQL Server, and the checkpoint process just goes to the buffer manager, asks the buffer manager for all dirty pages that we have changed in memory, and the checkpoint process writes those dirty pages out to our storage subsystem. The checkpoint process is implemented in a way that the checkpoint process processes in the first step all user databases. Means when you are changing a huge amount of data in your user databases, it can be the case that SQL Server can't checkpoint TempDb because you are starting the checkpoint process, and after 1 minute, SQL Server stops the checkpoint process because another checkpoint process starts. So in that case, SQL Server can't checkpoint TempDb, and your transaction log will grow. Okay? If you're hitting that specific case, you will also have an error message in the error log of SQL Server. I have seen it once in my life. Okay? So just think about that. You can have problems with the checkpoint process. SQL Server checkpoints the transaction log only when the transaction log is 70% full. That's also very, very important. And SQL Server is not writing out dirty pages. Because when SQL Server crashes, we are restarting and recreating TempDb. So it doesn't make sense to write those dirty pages out to the storage subsystem. Only the lazy writer writes out dirty pages. The lazy writer kicks in when SQL Server is in memory pressure. Okay? So when you have too less memory, or you have misconfigured your SQL Server regarding the maximum server memory setting, which is misconfigured by default, then the lazy writer can kick in and write out dirty pages to the storage subsystem. So from that perspective, you could also say, nah, doesn't really make sense or too much sense to put TempDb on SSD. Because we are not writing every time data out to TempDb. Okay? At the end, a few best practices. Just minimize the use of TempDb. Very simple, but very hard to achieve. Because as we have said, we are using TempDb the whole time. So for example, when we're thinking about execution plans, make sure that your statistics are accurate so that SQL Server, the query optimizer, can estimate our memory grants for sort and hash operations accordingly. If your statistics are wrong, are inaccurate, it can be the case that hash and sort operations are spilling over to TempDb and you are using again TempDb. When you're creating a temp table, think about it if you really need that temp table. Maybe you can work with a helper table within your application database. Also, when we are talking about sorting, ordering, and so on, think about that if you want to order your data within SQL Server. Ordering, sorting data is CPU intensive. When we are running SQL Server, we are paying on a core basis. We are paying for those CPU cycles. SQL Server isn't an application server. SQL Server is a database server. So the less CPU we are using within SQL Server, the more work we can perform within SQL Server. Use proper indexing. Indexing just means that we are pre-sorting our data physically in our storage. Means we can again overcome explicit sort operations in our execution plans. Okay? When you have specific performance programs in TempDb, just look on the latency times, then you can think about placing TempDb on its own physical drives. In general, you should avoid wait 5, wait 6. It's just very, very slow because we have to write out parity information. Writing out parity information increases our latency times. So when you are putting TempDb on different physical drives, normally you are using a wait 10 because you have a huge amount of spindles available which can work concurrently, or you are using SSD drives because SSD drives are very, very fast. As long as you are not doing mess in SQL Server, as we have seen yesterday. So even SSD drives is no guarantee that you have no performance problems. You can even have worse performance problems with SSD drives. Because in that case, your final bottleneck is the CPU. Because the SSD drive just serves your requests, and finally, you are hitting the limitations of your CPU. As we have said, the initial settings of TempDb are just crazy. The same as with application databases. So as I have done it here, on my SQL Server instance, please make sure that you have, please make sure that you have a good initial size. The nice thing is here, as I've said, when we're restarting SQL Server recreates TempDb from the model database. So when I'm restarting SQL Server, I want to restart you. Always on. Come on. Here we are. Nice thing about always on in SQL Server is always off by default. So if we started SQL Server, so we have created a fresh TempDb, but SQL Server is using those changes that we have applied to TempDb, as you can see. So when you are making changes to the file layout, number of files, default initial size, those things are persisted across restarts. So when you're restarting SQL Server, you have your additional files, you have your initial size of your data files. Okay? So SQL Server makes a copy of the model database, and afterwards SQL Server applies our user-defined settings that we have configured for TempDb. Don't shrink TempDb, don't shrink any database. You're just introducing a huge amount of index fragmentation, nearly 100%. And very, very important, to overcome latch contention, please make sure that you are using multiple files. As you have seen, even on a small machine, very, very easy to reproduce latch contention. We are just accessing in the main memory of SQL Server single-threaded those specialized system pages when we are creating temp tables and table variables. So that's the first thing that you should change on first day on your TempDb. Just assign multiple files to TempDb to overcome that specific limitation of SQL Server. So summary. We've got, yeah.
Can we back one second?
What?
The last one. Multiple files, and each physical file must have the same size. I'm just worried about the situation where we have multiple files, exact size of
Yeah.
these files. So Autogrowth should be off in that case.
No, you should avoid autogrowth. Autogrowth is bad. And if you are autogrowing, you should make sure that you are autogrowing with a fixed amount of megabytes. By default, SQL Server is autogrowing 10%. The percentage value is crazy because your autogrowth operations are taking longer and longer and longer and longer and longer over time.
I just wonder how to deal with that, because even if we have the same initial size of the TempDb files at the beginning, then after a few inserts into TempDb, it may differ.
No, because SQL Server is using a round-robin allocation, as we have said earlier. One extent in the first file, second extent in the second file, third extent in the first file, fourth extent in the second file. So SQL Server rebalances the allocations between both or between multiple files. So the files have almost every time the same size. And there's also a trace flag, don't ask me which one, just Google for it. You can also autogrowth all the files at the same time. If you really want to make sure that all files always have the same size. Okay? Other questions? As we have said, around 1/4 to 1/2 of files as you have CPU cores. But you really have to benchmark it with your specialized workload in which scenario your TempDb performs best. Of course, the more drives you have, the better it is. Of course, SQL Server is a database we are I/O bound. So storage very, very important. So in the beginning, I have talked why TempDb is important. As we have seen, we are using TempDb all the time, directly, indirectly. We have seen table variables are also persisted within TempDb. We have talked afterwards about specific problems in SQL Server TempDb, mainly latch contention. To overcome latch contention, we just have to apply multiple data files for TempDb, and we also have to make sure that SQL Server is able to cache our temp table. As you have seen, we went down from the query execution time of 57 seconds down to around 20 seconds just by reconfiguring TempDb and making one simple change. Okay. Thanks for attending, and I'm talking in the next session in a different room about managing very large databases. So if you want, you can follow me. Thank you.